Welcome back to the Deep Dive. We've got a really fascinating set of papers today, all about the latest and greatest in sound computing. Ready to dive in?
Absolutely, let's get to it.
All right, well, this first one really caught my eye. Synthetic audio helps for cognitive state tasks. It seems like text-to-speech models are getting even smarter, or at least more insightful.
Oh, yeah.
Apparently, they can figure out things about a person's cognitive state just from their writing. Things like emotions, fatigue, that sort of thing.
Huh, that is interesting. I mean, it makes you wonder what else these models are picking up on, right? Like, what other hidden patterns are they uncovering?
Exactly, and think about the implications. Sentiment analysis, lie detection, maybe even more. There's so much potential there.
Right, right. But speaking of potential, have you seen this paper about a new algorithm for speech processing?
Which one?
It's called Adaptive Central Frequencies Locally Competitive Algorithm for Speech. Kind of a mouthful, but the idea is really cool.
Okay, lay it on me.
So it's all about this new algorithm, LLC-CF, and how it works on neuromorphic chips.
Neuromorphic chips, those are the ones that are designed to be like the brain, right?
Exactly. Super energy efficient. And this algorithm uses something called sparse coding, basically representing audio information with just a few active neurons.
So like compressing audio to save power.
Yeah, pretty much. And the results are really promising. Imagine hearing aids that barely need charging but still understand you perfectly.
Wow, that would be incredible for people with hearing loss. That's a real game changer. Okay, so we've got emotional AI and super efficient hearing aids. What else is in store?
Well, how about voice cloning? There's this paper about Vivo, controllable zero-shot voice imitation with self-supervised disentanglement.
Voice cloning, huh? Is that like those deepfake videos but for audio?
Kind of, but even more advanced. This AI can actually clone voices it's never even heard before. Just from a short sample, it can generate speech that's practically indistinguishable from the original.
So that zero-shot thing they're talking about, it's basically learning on the fly.
Exactly. And think about what that could mean for things like personalized text-to-speech, voice dubbing for movies, even creating synthetic voices for people who've lost their own.
Yeah, the possibilities are pretty mind-blowing. And speaking of personalized TTF, there's another paper on that, right?
Yeah, LORE PTS, low-rank personalized text-to-speech. This one focuses on personalizing TTS with just a single recording, even if it's not studio quality.
Wait, really? Like if I just recorded myself chatting with friends?
Yep, exactly. They're using this technique called low-rank adaptation, or LoRa, to fine-tune the model to a specific voice, even with noise or informality.
So no more needing fancy recording equipment to make custom voices. That could be huge for accessibility and making things more inclusive.
Absolutely. And it's not just speech that's getting the AI treatment. Music is too. There's this paper called Music for All, exploring multicultural representations in music generation models. It's all about tackling Western bias in AI music.
That's an important topic for sure. AI should be able to represent all kinds of music from around the world.
Right. And researchers are looking at ways to adapt existing models to underrepresented music traditions, like using something called parameter-efficient fine-tuning, or PFT, to train them on smaller, more culturally specific datasets.
So like teaching these AI models new musical languages.
Yeah, you could do that. And while we're on the topic of music datasets, there's this other paper about Gemendo MaxCaps, a large-scale music caption dataset with imputed metadata. It's basically a massive resource for music understanding and generation.
Over 200,000 instrumental tracks with captions and metadata. What could researchers do with all that data?
I mean, imagine music retrieval systems that are way smarter, search based on mood, instrumentation, even lyrical themes. And of course, it could lead to more creative and sophisticated AI music generation, too.
That's incredible. Okay, so from composing music to how we experience sound, right? This next paper caught my attention. Advanced zero-shot text-to-speech for background removal and preservation with controllable masked speech prediction. It seems like AI is getting better at dealing with background noise in audio.
It's true. And what's cool is this new TTS system can actually choose to either remove the noise or keep it, depending on what you want.
So you could clean up a noisy conference call but still have the ambience of a street recording if you wanted to.
Exactly. And speaking of cleaning up audio, there's this other paper, a hybrid model for weakly supervised speech dereverberation that's tackling reverberation.
Reverberation, I think I need a quick refresher on what that is.
Think about singing in the shower. That echo you hear, that's reverberation. It can make recordings sound muddy. This new model is using a really interesting approach to dereverberation. It doesn't need a ton of information about the recording space.
So you can clean up those echoey recordings without a bunch of extra data. That's pretty impressive. Seems like AI is getting really good at manipulating all these subtle aspects of sound.
It really is, and this next paper dives into those subtleties even more, towards understanding of frequency dependence on sound event detection. It's all about how different frequency bands play a role in identifying specific sounds.
So sound event detection, or SED, that's like those security systems that can detect breaking glass, right?
Exactly. And this research is all about understanding how different frequencies affect that detection process. Like, just like our ears are tuned to different frequencies, these algorithms are learning to prioritize different bands depending on the sound they're looking for.
It's a great analogy. And speaking of creating realistic soundscapes, have you seen this paper about a system that uses visual cues to generate 3D audio?
Visual-based spatial audio generation system for multi-speaker environments. Oh yeah, that one is wild.
Seriously, how does that even work?
It's a combination of object detection, depth estimation, and spatial audio techniques. Basically, it uses visual information to place sounds accurately in a 3D environment.
Wow. Imagine watching a video of a band playing, and each instrument's sound is coming from the right spot in 3D space. Sound designers are going to love this.
It could definitely make creating immersive audio a lot easier. Okay, now for something a little different. This paper, Learning Source Disentanglement in Neural Audio Codec, is all about separating different sound sources within a recording.
So like untangling the individual instruments in a song.
Yeah, or isolating someone's voice in a noisy environment. They've created this model called SD codec that can actually separate out different sounds and assign them to distinct codebooks.
So you could remix reality by isolating and manipulating individual sound elements. That's really cool.
It is pretty amazing what's possible now. And finally, there's this paper on robust Persian digit recognition in noisy environments using hybrid CNN by GRU model. It's all about improving speech recognition, specifically for spoken digits.
Speech recognition is so important these days. I mean, it's everywhere, voice assistants, dictation software, you name it. And being able to recognize digits in noisy environments is crucial for things like voice-controlled banking.
For sure. And this paper introduces a hybrid model that combines CNNs with BiGRUs, which are two different types of neural networks.
So they're mixing and matching AI techniques to create something even more powerful.
Exactly. And the results are impressive. They've significantly improved the accuracy of Persian digit recognition, even with background noise.
That's really exciting. It seems like we're seeing a trend here combining different AI approaches to tackle complex problems in new ways. It's pretty incredible what's happening in sound computing these days.
Yeah, from detecting emotions in text, to composing symphonies, to untangling the threads of complex audio signals. And we haven't even talked about the tools and frameworks that are driving all this innovation.
That's right. There's a whole other layer to explore there. But we'll have to save that for next time.
It's like giving researchers and developers the keys to the sound creation kingdom.
And speaking of democratizing technology, you mentioned multitask learning for audio processing. What's that all about?
Yeah, so there's this paper, MT2KD, towards a general-purpose encoder for speech, speaker, and audio events. It's about training one model to do, well, multiple things at once.
Like a Swiss Army knife of audio AI.
Pretty much. This one can handle speech recognition, audio tagging, and even speaker verification.
All with the same encoder. That's impressive. So instead of building separate models for each task, you just train one really versatile model.
Exactly. More efficient, more adaptable. Speaking of adapting, we've got to talk about the latest in speech recognition. KNN for whisper and its effect on bias, and speaker adaptation. This one's all about tweaking whisper without a complete retraining.
Whisper, the speech recognition model, I know that one. But what's this KNN thing?
KNN stands for Key Nearest Neighbor Search. It's a way to fine-tune a model like Whisper without starting from scratch, which can be, a pretty resource-intensive process.
So you're basically making it work better for specific accents, genders, age groups, that sort of thing.
Right, and that's really important for tackling bias in these systems. We want technology that works well for everyone, right?
Absolutely. Speaking of which, there's this other paper about using both audio and visual cues for better speech recognition.
Whisper Flamingo for multilingual audiovisual noise robust speech recognition, combining Whisper with AV Hubert for video processing.
It's like how we use lip reading to understand speech in noisy places, right?
Yeah, sort of. It's taking advantage of both audio and visual information. Really impressive results for multilingual speech recognition, even with a lot of background noise.
That's great news for things like video conferencing and transcription, especially across different languages. It's interesting to think back to that first paper we talked about, the one about TTS models detecting cognitive states from text.
Oh, yeah, the one that could sense emotions and fatigue just from writing?
Yeah, that one. It really gets you thinking about the ethical side of all this, doesn't it?
I mean, as these models become more sophisticated, we have to be careful about things like privacy, security, even potential manipulation.
It's a powerful technology, and we have to make sure it's used responsibly.
Absolutely. But on a more positive note, think about those AI-powered hearing aids we talked about earlier, using neuromorphic chips to make them super efficient.
Yeah, it would be amazing to see that become a reality. Hearing aids that are discreet, comfortable, and can actually understand speech even in noisy environments.
And not to mention energy efficient. Imagine barely needing to charge them.
It's remarkable how all these different areas, speech recognition, voice synthesis, audio processing, are coming together to create this incredible future for sound.
Yeah, and we're just getting started. Think about AI composing music, sound in therapy, all sorts of new possibilities. It really is an exciting time.
And we haven't even talked about the tools and frameworks that are making all this possible.
Right, like Amphion, the open source toolkit we mentioned earlier, it's making sound generation so much more accessible.
Collaboration and open source tools are so crucial for innovation.
Totally. It's all about sharing knowledge and building on each other's work. Who knows, maybe someone listening right now will be inspired to make the next big breakthrough.
This field is just exploding with potential. We've barely scratched the surface in this deep dive. But for now, I think we've covered a lot of ground.
We have. From the tiniest algorithms to models that can generate entire symphonies, it's clear AI is transforming the world of sound.
And it's happening at an incredible pace. So much research, so many new ideas.
It's really an exciting time to be following this field.
It really is mind-boggling when you think about it. From those tiny algorithms that make hearing aids more efficient to AI composing entire symphonies, it's incredible.
And we've only just dipped our toes in the water. So much we didn't even get to like sound in therapy or AI tools for sound design in movies. The possibilities are endless.
It makes you wonder what our sonic world will be like in a few years, right?
Oh, absolutely. Imagine, interacting with technology in totally new ways, surrounded by soundscapes that are personalized to our emotions, our preferences, everything.
It's a pretty exciting future, but with all this power comes a lot of responsibility too, right?
Definitely. I mean, the ability to create and manipulate sound so precisely, it raises all sorts of ethical questions. Authenticity, privacy, the potential for misuse.
Yeah, we have to be really thoughtful about how these technologies are developed and used, making sure they benefit everyone, not just a select few.
Couldn't agree more. It's a responsibility we all share: researchers, developers, policymakers, everyone.
It really is. The future of sound is in our hands.
And ears.
Right. We need to be listening carefully to make sure we're guiding these innovations in a direction that's both technologically advanced and ethically sound.
This deep dive has given us a lot to think about, that's for sure. A future where sound is more personalized, more accessible, more immersive than ever before.
We've covered a lot of ground, from those complex audio signals to the amazing potential of AI.
And we've seen how AI is not only improving existing technology, but creating entirely new ways to experience and interact with sound.
And this is just the beginning. It feels like there are new breakthroughs happening every day.
Absolutely. This field is exploding with potential. So if you're listening, keep exploring, keep asking questions.
Who knows? Maybe you'll be the one to make that next big discovery.
Until next time, keep listening, keep innovating, and keep pushing the boundaries of what's possible in the world of sound.
Thanks for joining us on this deep dive. 745.